Before you can take on the responsibility of maintaining electrical equipment, you have to know how each piece of equipment operates. You also have to have a thorough understanding of the fundamentals of electrical theory. A lot of the equipment that you work with is powered by electricity. To fully understand how this equipment operates, you need to know what electricity is and where it comes from. Electricity is a form of energy. In simple terms, electricity can be defined as the movement of electrons. Electrons are electrically charged particles that exist in atoms. The forces related to the movement of electrons are often referred to as electromotive forces, or more commonly, as voltage. There are 6 basic sources of energy that can be used to detach electrons from their orbits and keep them moving. In other words, there are 6 basic ways to produce voltage. They are friction, heat, pressure, light, chemical action, and magnetism. Friction is the rubbing of one material against another. For example, when a balloon is rubbed on the carpet, electrostatic charges are transferred to the surface of the balloon. These charges create a detectable electrostatic field. The effect of the electrostatic field holds the balloon against the wall. The type of electricity that's produced by friction is called static electricity. Static electricity is used in a few applications, but more often than not, it's just a nuisance. The wires in this thermocouple are made of 2 different metals. When heat is applied at the junction of the 2 wires, a small voltage is produced. In this case, the measurement is in millivolts, that is, thousandths of a volt. The amount of voltage is related to the amount of heat that's applied. The voltage can be measured and used to determine the temperature of a component or an area. Pressure is the source of voltage that's used in this vibration monitoring device. The pressure is applied by vibrating equipment to a crystal that's inside the device. The pressure on the crystal releases electrons from their orbits, and electron movement or current flow occurs. The amount of pressure applied can be converted into vibration measurements. Light can also cause atoms to release electrons. This device is called a solar cell. When light shines on the material in the solar cell, an effect called the photoelectric effect occurs. Friction, heat, pressure, and light are used primarily in specialized applications. The sources most commonly used to produce voltage are chemical action and magnetism. Chemical action is actually the energy produced by a chemical reaction. It's the source of voltage that's used in batteries. In this simple electrical circuit, the 2 magnets provide the magnetic field that's needed to produce voltage. The conductor is a loop of copper wire. Copper is a material that electrons or current can flow through easily. The wire is connected to a light bulb, which will light when current flows through it. The third thing that's needed is relative motion between the conductor and the magnetic field. In this example, that requirement can be met by moving the conductor. In another arrangement, the conductor could be stationary while the magnetic field moved. In any case, what the term relative motion means is that either the conductor or the magnetic field has to move. The voltage that's produced in this way is usually referred to as induced voltage. The magnetic field, the conductor, and the relative motion induce a voltage in the conductor. One way to determine the amounts of current, voltage, and resistance in a circuit is to measure each quantity directly. To do this, you have to use appropriate test instruments, and you have to connect the instruments correctly in the circuit. We'll use some simple drawings to show how current, voltage, and resistance measurements are made. In addition to the basic electrical quantities of current, voltage, and resistance, there are other quantities associated with electrical circuits. We're going to look at 2 of them, power and electrical energy. Ohm's law is a convenient way of expressing the relationship between current, voltage, and resistance in electrical circuits. When you know this relationship, you can calculate any of the 3 values when you know the other 2. You can also predict what will happen in a circuit when conditions change. Besides using Ohm's law to determine values for current, voltage, and resistance, you can also use it to predict what will happen in a circuit when conditions change. To see what this means, let's look at the formula again in the arrangement that we used to find the value for current. One common type of electrical circuit is a series circuit. A series circuit is a circuit that has a single current path. The components in the circuit are connected end to end, and the same amount of current flows through each one. Okay, we've looked at current and resistance in a series circuit. Now let's look at one more type of quantity, a voltage drop. A voltage drop is the amount of voltage across a resistor in an electrical circuit. Many electrical circuits are parallel circuits. A parallel circuit is a circuit that contains two or more paths through which current can flow. Each current path may be referred to as a leg or a branch. A series parallel circuit is a combination of a series circuit and a parallel circuit. The series portion has the characteristics of a series circuit, and the parallel portion has the characteristics of a parallel circuit. Let's look at an example. Calculating voltage, current, and resistance values for a series parallel circuit is no more difficult than calculating these values for series circuits and parallel circuits. Just be sure to analyze the circuit carefully and divide it into the correct portions. Anytime there's relative motion between a magnetic field and a conductor, a voltage is created in the conductor. This process is called induction. When the process occurs, we say that voltage is induced in the conductor, or we call the voltage that's created an induced voltage. What all this means is that a change in current flow through a conductor will cause a change in the electromagnetic field around the conductor. If the current flow doesn't change, the field won't change either. There is a relationship between the voltage and current on the primary side of a transformer and the voltage and current on the secondary side. To understand this relationship, you need to keep in mind that although a transformer changes voltage and current, it doesn't change power. Self-induction is present in every electrical circuit. It always opposes a change in current, so it has the effect of keeping current from building up instantaneously when it's first turned on and stopping instantaneously when it's turned off. The actual interval of time that elapses before current flow overcomes the effect of self-induction is very small, only a fraction of a second, but there is a time delay. Because of self-induction, when current flow is turned on, it increases to its maximum value gradually. When it's turned off, it decreases gradually until it reaches zero. The amount of voltage that's produced in a circuit by self-induction depends on the amount of inductance in the circuit. Inductance is a physical property of all circuits that opposes changes in current. All circuits have some inductance, but some circuits have more than others. Since inductance is a physical property that's present in all conductors, it affects both DC and AC circuits. In a DC circuit, the presence of inductance can cause problems when the current is switched off. The arc is actually current flow through the air across the open switch. The arc formed because the inductance in the circuit kept current flow from stopping instantaneously when the switch was opened. Arcing is undesirable and it can damage a switch. DC circuits are usually designed with protective devices to minimize arcing. On the other hand, some AC circuits include devices called inductors, which enable the circuit to make use of the properties of inductance. Capacitance is a physical property of all electrical circuits that opposes changes in voltage. Capacitance is often added to AC circuits to counter the effects of inductance, which is a physical property that opposes changes in current. When the inductance in a circuit would limit current flow more than a desirable amount, additional capacitance can be added to bring the current flow up to the level that's needed. One thing that you need to remember about capacitors is that all capacitors and all systems that have a significant amount of capacitance can be dangerous. Capacitors retain their stored energy even after their power supply is cut off. To be safe, always assume that a capacitor is charged unless you can verify that it is not.